What is divergence? To answer the question, we must understand what is a vector field. Imagine that we have particles moving throughout all the space. At each point on space, this can be represented by an arrow pointed in the direction of motion. The length of the arrow represents the amount of the motion. At any given moment in time, all the arrows that are located throughout all the space can be referred as vector field. At each point in space, the rate at which particles are being generated per unit volume is what we refer as the divergence of the vector field at this point in space. If we have a volume of any shape or size, then the divergence of all the points inside the volume is what determines the rate at which the volume as a whole is generating or absorbing particles. Here the vector field represents the force of gravity in the region of space. Darker the color represents the strength. More darker the region is more strength. Less darker or softer the region is less strength it contains. Imagine an electric field. We have positive charges and as well as we have negative charges. In this vector field, each vector describing velocity of field lines at that point. Notice when you do this, the field lines behave in a very strong non-physical way. On some points like these ones, the field is just coming from nothingness, as if there is some kind of source there. Here divergence is positive. Remember, divergence of a vector on some coordinate is just a number. More the magnitude, more the powerful the source is. Some other points act more like sinks, where the field lines disappear to nothingness. Divergence of a vector field at some specific coordinate is just a number. More the number is the number, stronger is the field. Here divergence is negative. Divergence is also positive if it's just the field lines coming into it from one direction slower and coming out of it faster in other direction. It's still a spontaneous generation. Here from the perspective of outside world, the number of particles entering the region is less than the number of particles coming out of it. The region of space generates particles so that it has a positive divergence. Here from the perspective of outside world, the number of particles entering the region is more than the number of particles coming out of it. The region of space absorbs particle so that the region is called as the negative divergence. Here from the perspective of outside world, the number of particles entering the region is equal to the number of particles coming out of it. The region of space is neither absorbing or generating. The region of space has zero divergence. Let us discuss some brief theory on divergence. Divergence of a vector quantity indicates how much the vector quantity spreads out from the central certain point, and it is a measure of how much a field comes together or flies apart. Consider a water flowing through a large pipe. Here is a pipe and it is water is flowing through this. Now it has a smaller pipes joining to it. It has the smaller pipes here. It has the two pipes joining to it. Hence, as the water flow, more water is added along the way by the smaller pipes. Hence, the mass flow rate increases as the water flows. In another case, consider that there is a leakage in the pipe. Let's say there is a leakage here or here. Hence the mass flow rate decreases as it flows. Thus change in flow rate through the pipe, whether it increases or decreases, is called divergence. If flow rate increases, we call it as a positive divergence, and if flow rate decreases, we call a negative divergence. Divergence denotes only the magnitude of change, and so it is a scalar quantity. Divergence of a vector A is given as divergence dot a, or we have a del operator dot a. So del operator we have I delta upon delta x plus j cap delta upon delta y plus k cap delta upon delta z with dot product of the vector a, that is ax I cap plus ay j cap plus az k cap. Ax, ay, az is the component of the vector in x, y, z direction respectively. So we have the I cap dot product delta ax upon delta x plus delta ay upon delta y plus delta az upon delta z. That's how we define the divergence of the operator A. Let us discuss some examples. If we are standing on the edge of the pond, if we sprinkle some dust needles or particles, if it collects, it has a negative divergence. If it spreads out, it has a positive divergence. So there are some examples of positive divergence and negative divergence. So positive divergence is some source, faucet, and negative divergence is sink, drain. So there is some vector fields here, f of xy equal to x I cap plus y j cap. This is how the vector field looks like of this vector x I cap plus y j cap. Okay. So if we feel like y equal to 0 here, y equal to 0, so x I cap. So this is the increasing function. If we increases, the vector increases. The magnitude specifies the amount. Okay. If it is long, here the vector field is more, here the short, the vector field is lower. Okay, and it has zero divergence. It also has the positive divergence as the rows is increasing. Let us some examples where here a equal to x square I cap plus 3xz square j cap negative 2xz k cap. Well, the divergence of something is very easy because we have to just derivative with respect to s, we have to derivative with respect to y, we have to derivative with respect to z. So we have here 2x and this is just my negative 2x and it is independent of y. So the answer is 0. So you have the 0. So the next vector is v equal to xy I cap plus 2yz j cap plus 3z x k cap. Okay. So the way I am talking with this one, the same proceed with this one also. Just derivative with respect to x, this is y, derivative with respect to y, answer 2z, and derivative with respect to z, we have 3x. That's the required answer. If we have some given points like 1, 2, 3 on the region of space, the divergence of vector will be a number. Next is C vector is y square I cap plus 2xy plus z square j cap plus 2yz k cap. Okay, the same way it proceeds. First derivative of this one with respect to x, it is 0. 2xy plus z square, derivative with respect to y, this is 2x, and 2yz, derivative with respect to z, we have answer to y. This is the required answer to this problem. सबसे फन पार्ट यहाँ पे हम अभी देखेंगे कि हम डाइवर्जेंस को कैसे अपने डेली लाइफ में अब एक्सपीरियंस करते हैं. आई एम श्योर दैट हम सभी ने बेसिन यूज़ करते हैं, वाटर बेसिन यूज़ करते हैं अपनी हाथ साफ करने के लिए. तो आप आज ही जाके अभी वीडियो देखने के बाद जाके एक्सपीरियंस कीजिए डाइवर्जेंस कैसा होता है. ठीक है, तो यहाँ पे एक बेसिन है. ठीक है, आप जब टैप खोलते हैं पानी निकलता है, पानी निकलते यहाँ पे सरफेस के ऊपर यहाँ पे पड़ गया. ठीक है, यहाँ पे आप देख सकते हैं कि ये वाटर सोर्सेस यहाँ पे पड़ के कैसे यहाँ से बाहर निकल रहा है, जैसे कि ये एक सोर्स है. ठीक है, अगर W एक वेक्टर है जो कि वाटर फ्लो को रिप्रेजेंट करता है, तो इस पॉइंट पे इसका डाइवर्जेंस पॉजिटिव है. ठीक है, इस पॉइंट को छोड़ के आप यहाँ पे देख लो, यहाँ पे देख लो, यहाँ पे देख लो, कहीं पे भी जगह पे देख लो, जितना पानी उस पॉइंट से जा रहा है उतना ही पॉइंट आ रहा है. ठीक है, तो इसीलिए कहीं पे भी ये सब सारे जगह पे डाइवर्जेंस ऑफ W वेक्टर 0 है. अब यहाँ पे देख सकते हैं इस पॉइंट पे सारा वाटर इकट्ठा होके यहाँ से जा रहा है. ठीक है, जब निष्कासित होता है ना, पानी जाता है वाटर नीचे नाले में, तो इस पॉइंट में डाइवर्जेंस ऑफ द वेक्टर W नेगेटिव है और हम उसे कह सकते हैं सिंक. इसको हम कह सकते हैं सोर्स, और ये ना सोर्स ना सिंक कुछ भी नहीं है. ठीक है, तो यहाँ पे हमारा डाइवर्जेंस खत्म हो जाता है। तो नेक्स्ट में देखेंगे लैप्लासियन। लैप्लासियन खत्म होने के बाद कर्विलिनियर कोऑर्डिनेट स्टार्ट करेंगे।